Welcome everyone. So this is the Alternative Propulsion Engineering Conference. We're keeping it rough and raw. We are in Mark's lab, and he is going to be doing some experiments and apparently drinking a few beers while we're here. But I want to thank everyone for joining us. We have a lot of folks with us, and so this could get messy if we don't try and keep things organized. So my hope is we kind of laid out some Zoom room etiquette. I mean, one of them is just professional behavior, right? Please raise your hand to ask questions or ask questions in chat, and then I will unmute you. And that way, hopefully we can all kind of keep it muted as we're going. And that way, one person could talk. Our guests today are Mark McCandlish and David Alzofon. And the reason that we wanted to have them was a lot of the work that Mark Sokol and his team are doing, really, they'd asked a lot about the ARV last time and, and how that tied into it. And so that kept coming up. And then they've been working very intently on Alzofon's work. And so, we really appreciate Mark and David joining us. We'll probably start with Mark. And the reason is he is only with us for a short time. He has to get to work later. And that's, again, thank you both for joining us. This is really exciting. So again, we're going to try and keep everybody muted. If you have questions to ask, I have my chat up on the side, and I will keep an eye on all of that. And just let me know if you have questions, Okay, and so, oops, I just lost my mouse. There we go. Okay, so we will get started. Let me, I'll unmute Mark again. Mark, I apologize for interrupting you, sir.
Let's see, can you hear me now?
Yeah, perfect.
Okay, I saw something come up on the screen about unmuting my own mic, so I'm not sure that I didn't know that I had that control, but if I need to do something, just let me know. Well, I want to thank you, Tim, for inviting me to this conference, and I'd like to welcome all of the extended audience. It's been a long time since I've had occasion to talk about the things that I've been exposed to in regards to the technology. Obviously, some of this material is way above my pay grade in terms of the physics involved. It's one of the reasons why having people like Mark Sokol and some of the other people that I've had the privilege of corresponding with over the years, like Hal Putoff and Tom Valone and a number of individuals, and Paul Murad, it's been especially helpful for me to gain some insight as to how this device functioned. A lot of what I've come up with has been based on things that I've read subsequent to the initial eyewitness testimony about the craft and how it was put together. I've encountered probably 3 different witnesses that at some point have either had exposure to the technology, have seen it up close and personal, or had family members who actually worked on it. So that is, those are sources of information that I've drawn from over the last 30 years ago. It's hard to believe it's been that long, but since 1988. So what I have to offer now is probably my best guess as to how the system is put together, how it functions, what the components are made of, how they orient to one another. And I'm sure that Mark and some of the other people that will be listening in will probably have some insights that they can offer as to how these components relate to one another and what the real underlying function is. So I'm happy to contribute, and let's get going.
Well, Mark, so I talked to Mark Sokol briefly, and he had said that Jerimiah Hansen probably had a bunch of questions to ask. I think Jerimiah is on the call. Actually, let me here. I'll unmute him.
Yeah, not Jerimiah Hansen. I'm not sure where that name came from.
Oh, I'm sorry. I'm sorry about that.
Jerimiah Popp. We did have quite a few questions. We were going to actually wait for Mark to sort of speak because Mark Sokol and I both thought that Mark McCandlish may actually cover many of our questions in his talking about it. So I think we're just going to wait till the end and hold off.
Ah, okay.
Okay.
Okay. And then let me see. So let me unmute Mark Sokol and okay.
Yeah. So Mark, how did you come about, how did you discover this concept of the ARV? How did this, what's the backstory behind it?
In 1988, November 12th, there was an air show at Norton Air Force Base, which has since been closed. It's in San Bernardino, California. They had an annual open house and air show, and they'd have all these aircraft that would fly in from different parts of the country. They'd have static displays, and as an aviation artist, this was a terrific opportunity for me to take my camera and go down and take pictures of rivet lines on planes, so that when I did highly detailed illustrations of the different aircraft, that I would have all the features correct. I mean, there are literally people in the aviation art industry and fans of that genre that will literally count the number of rivets on a panel and say, he's left out two rivets on that panel right there. So, I mean, I even got serial numbers off of, missiles and things like that, that I would include in the illustrations when I would do them. So that was my main reason for wanting to go to this air show at Norton Air Force Base. And I had a colleague, a friend, who I'll just call Brad for the sake of this discussion. Some people know what his last name is, and I've tried to discontinue using his name, principally because disclosing of his name has brought a lot of unwanted attention to him and his career. I don't know specifically what, if any, or how much harm has come to him in terms of his career because of my disclosures. I have to say that not being a journalist, not having a background in journalism, I didn't really know when I was being prodded by people in the Disclosure Project to name names and things like that, which I did, that this could be potentially and very harmful to the individuals who had been the original source of the material. In the case of Brad and another individual who had occasion to see one of these things up close when he was actually in the service in 1973 at Edwards Air Force Base, there were a lot of details that were not only seen by these individuals, but were also explained to them, and, basically to understand what they were looking at. And so my friend Brad and I were going to go to this air show at Norton Air Force Base, and last minute I got called off to do a couple of illustrations for Popular Science magazine over the weekend. It was about $7,000 worth of illustration work that I couldn't pass up, for such a short amount of time to actually complete the work. So I didn't go to the air show, and Brad went. And about a week or so passed, and I hadn't heard from him. So I called him up, asked him how he liked the air show, and this was a person who was generally very enthusiastic and animated, and he sounded completely different. He sounded like he had been emotionally drained. And so I asked him what was wrong, and he didn't really want to talk about it on the phone. So we went and had lunch together, and he sat across from me and explained to me that he had seen these three flying saucers in a hangar. And initially he made it sound like it had been one of the large hangars. There was a very large Quonset hut style hangar at Norton Air Force Base, facility that's now owned by Lockheed, I believe. These were the sort of Quonset hut style hangars that have sort of the arching roof. Initially it was believed that that was the location where the exhibit occurred, but later on, through a third party that knew both of us, Brad disclosed that he and a number of other officials, a number of people that he had been associated with, and people who were, for example, Alan Cranston, the late state senator from California, the late Congressman George E. Brown Jr., who at the time was the chairman of the Congressional Committee on Space Science and Advanced Technology. these people were all in this group of dignitaries, both military and civilian, that got on a military version of the Boeing 727, and they flew from Norton Air Force Base up to Air Force Plant 42, which is in Palmdale. A lot of people just consider it the Palmdale Airport. It was actually a facility that was built, from what I understand, by Lockheed back in the 1960s. And the hangar that is now serving as a Skunk Works hangar was the original construction site for the L-1011 Lockheed TriStar airliner, which did not prove to be as successful and as durable as the McDonnell Douglas DC-10. So anyway, they disembark from the aircraft, go into the hangar, and the gentleman who was basically serving as a sponsor for Brad to get into the show was one of the top management types from Lockheed Martin, their Skunk Works division. And he seemed surprised at the extent of the exhibit that was there. Over time, I learned that the individual aircraft that were on display were actually, they had a blind that was maybe 9 to 10 feet tall around each of the aircraft, so that while you might be standing next to one particular aircraft in the display, you wouldn't be able to look across the floor of the hangar and see the other aircraft that were there in the hangar at the time. So it was a situation where you would be escorted from one exhibit to the next, and the individual aircraft would be shown to the guests that were there. And so he went through a description of the different aircraft that he saw. He described a number of unusual hovercraft vehicles that were there. There was a kind of an unusual short takeoff and landing or stall type aircraft that had a pair of wings on the fuselage that looked like a stepped series of almost like Venetian blinds with a fence out on the wingtips that held them all together, and the individual wings could all rotate, producing a different angle of attack. But when they were rotated fully upward, the leading and trailing edges would all come together, so that this set of individual wings would actually become a very broad and long sweeping surface. And then just ahead of the very first wing at the top front part of this assembly was a small turbofan engine with a kind of duct. Imagine a funnel that had been squashed and flattened out on the end. The small end was stuck in the back end of the engine. And what this did was it took the exhaust stream from the small turbofan engine and it spread it out over the entire leading edge of the first wing. So basically it was an aircraft that was making the ultimate exploitation of what's called the Cowanda effect, where basically you can take like a piece of paper like this, and you blow over the top edge. And if you blow hard enough, it actually produces lift, because the air passing over the top surface of the wing is moving faster, so it produces a lower pressure than beneath the wing, and basically you have lift, massive amount of lift created using this particular design. And then right smack dab down through the middle of the fuselage of the aircraft was the same GAU-8 7-barrel Gatling gun, 30mm Gatling gun that's used in the A-10 Warthog, which is one of the anti-armor ground support type aircraft that has been around for a long time. It was built by Republic Aircraft many years ago. So this thing was like a strange looking version of the A-10 with an unusual wing configuration. It wasn't very fast. Apparently was quite maneuverable. And so this was one of the aircraft among many that were in this exhibit. There was also I guess there were 2 or 3 different variations of the flying wing aircraft that were part of the Air Force competition to build the B-2 stealth bomber. Lockheed had come up with a version that looked like a large, very ungainly version of the F-117A stealth fighter. Boeing had come up with what ultimately won the I'm sorry, it was Northrop that came up with an aircraft that ultimately wound up winning the B-2 competition, which was the rather elegant B-2 Spirit that we know of today, which had a very beautifully blended wing body design that incorporated the fuselage right into the design of the wing, had a number of features that made it particularly stealthy. Sawtooth trailing edge on the wing, and the inlets for the engines were buried in the upper part of the wing to prevent the rotation of the turbine blades from being exposed to radar and so forth. Anyway, so skipping all the other aircraft that were in the exhibit, the last part of the display involved these 3 flying saucers, the so-called Alien Reproduction Vehicle, ARV, or they were also nicknamed the Flux Liner, FLUX liner. Flux is a term used in electricity to describe a high level of charge, from what I understand. So these aircraft, these flux liners, were sitting in the hangar, hovering several feet off the floor, with no visible support from above, no landing gear extended below. Although I understand from one of the witnesses that I spoke to in 2014 that the more advanced version of this type of propulsion system, which was built into what looked like a black lenticular lens-shaped disc, did have a type of landing gear that would extend from the ventral surface, the underside of the aircraft, and the entire propulsion system would be shut down, and it would be rolled into the hangar using small electric motors that were actually in the drive wheels that made contact with the ground. And this was largely because the electromagnetic field that was produced by this particular more advanced version of the Alien Reproduction Vehicle, it was so powerful that the craft would interact with the metal structure of the hangar and it would raise havoc. So they had to turn the whole thing off and then just basically scoot it in on these little wheels into the hangar.
Well, now, Mark, if I could jump in really quickly, let me try and do a screen share. I have a photo that you drew of this, and hopefully I won't goof it up. Hopefully you guys can see all of this fairly well. Yeah. So this looks like this is the actual hangar, right? That you're describing. Yeah.
That's the inside of the Lockheed Skunk Works hangar. Yeah. And those are the big bypass doors on. There's actually bypass doors on both sides. During the production run on the L-1011, they could actually bring sub-assemblies of the aircraft in on one side, and it went through kind of a production chain where they would attach the wing and the engines and so forth as the aircraft would go through the various stages of their construction. So they had bypass doors that were both on the front and the back side. That would be the east and the west sides of the building, which was located at the west end of the Plant 42 complex.
Okay. Sorry about that.
One of the things that the eyewitness Brad had explained was that the craft, or the 3 different craft, shared the same kind of proportions in terms of the size of the the crew compartment, which what you see there is actually the upper half of a sphere, a composite sphere. There is there's a process that they have. I'm trying to remember what it's called, where they have a mandrel that they begin wetting a composite thread, and they wind it around this mandrel and create a sphere that has all these different windings of a synthetic or a composite, like a carbon fiber or fiberglass type thread, that are wound all through the structure of the sphere, which means that it has an incredible amount of strength. And then, of course, it's heated and cured and so forth. And then they cut an opening into it, and they put in a metal frame and what looks like your old style, Captain Nemo style submarine door, with the pins that go out into the frame of the door, with a sort of a vacuum tight or an airtight seal around the edges, and a big wheel in the middle that you turn to either insert or withdraw the pins from around the edges of the door to withstand the pressure that's either inside or outside of the vehicle. There was also a kind of a blending that was added to the sphere afterwards, and in the way that these craft were constructed, the crew compartment sphere, at least in the smallest version, was actually designed so that the crew compartment sphere was actually split at the belt line around its entire perimeter with a series of explosive bolts. And the flange that flares out at the bottom, you can see this in the largest example, is probably the easiest to see in this illustration. But this flange would actually capture the primary windings, the coils that were in that little flat section that's right at the belt line, the midpoint of the crew compartment. That's where the coils are that are around the outside of this system. And then the various panels that go around the bottom of that skirt there are literally attached using a series of Zeus fasteners on the upper edge, and then along the mating edges that run vertically around the perimeter of the craft, and then there's another set of Zeus fasteners on the bottom.
So you're saying that they could remove, and sorry, I know you can't see my hand. They could actually remove the top. Then you're saying there were explosive bolts around the top, and you could blow the sphere off. Is that what you're describing?
This was part of the egress system, the ejection system. There's a central column that runs down through the middle of the smallest version of the craft. Now, I'm not sure what the layout was in the larger designs. Let
me click over to this one. I should apologize.
Yeah, that's a computer generated illustration that's not completely accurate in terms of the scale and the proportion of things, but it does show a pretty clear there you go, outline of what the different components are, where they're located. You can see in the cross section over on the right side there where that one panel comes up on the skirt, and there's just a little bit of a cross section of the coils. That, of course, is not correct in terms of the number of layers of coils. There were 16 layers of coils. The coils were a square cross section copper windings that were 1/4 of an inch across, with a spacing between the coils that was 3/8 of an inch, both top to bottom, side to side. And then there was an additional margin of dielectric material, or this kind of a coarse material that was used in the casting of these things, above and below, probably for wear and tear over the lifetime of the vehicle. But the skirt panels were literally fastened to the outer edge of this ring with the coils in it using Zeus fasteners. but the flange that was visible in that earlier drawing that you had up there, Tim, was actually used to, you can see right there on the largest vehicle, there's kind of a blended flange that comes out on the sides. And that was actually used to trap the coils at the midpoint between the upper and the lower halves of the crew compartment. And that was what held those in place. So the system was designed so that in an ejection sequence, the explosive bolts around the perimeter of the crew compartment would blow off. The top half of the crew compartment in the smallest version would come off, and with it, it would pull the outer sheath on that central column that the ejection seats were all mounted to. And then once this had cleared, yeah, there you go. You can kind of see a pair of rails above each of those ejection seats. And from what I understand, the top half of the crew compartment would come off, and once it was a certain distance away from the rest of the vehicle and something below 18,000 feet, the ejection seats would slide down those rails off of the upper half of that column that's above the rotating disc that also serves as kind of a floor beneath the feet of the pilot.
Yeah. So Mark, if I could jump in, I see, and I should apologize, I can't really see the chat screen. Hopefully nobody is chatting me right now, but it looks, I don't know if you can see my mouse, but underneath each one of these chairs, there is a little square that you've drawn on the floor. So it looks like when this top half of the cylinder comes off, then what you're saying is the chairs would slide down on the rails right out of the bottom of it, and presumably they have parachutes or something attached. Right?
Yeah. Well, these were the standard ACES II ejection seats that you find in aircraft like the F-4 Phantom, manufactured by McDonnell Douglas. There was, of course, this drawing is somewhat abbreviated from the cutaway illustration that I did. It was more or less just a line drawing. It didn't have all the shading and coloration that this one here does. The ejection seat actually had a pair of small oxygen tanks that were underneath the lower seat cushion on the ejection seats, and those rails went all the way down to just a section just above where that rotating disc is located. You can also see the controls on the pilot seat there, which looked like a little ball on one side and a big rheostat on the other side that moves forward and backwards, controlling the amount of power. And then the selection of where the power was sent to in the capacitor array in the bottom of the craft was controlled by that ball-like mechanism. Now, it's only been in more recent times that I found that my original visual description of that control mechanism was not correct. That there actually was your typical pilot's control stick, very much like the one that you would see on the F-16, which had a number of buttons and triggers and things on it that would help to activate or deactivate certain features in the propulsion system, or the synthetic vision system that involved the different cameras that are on the outside of the crew compartment. This was basically how they were able to see where they were. It was my understanding that these cameras could be operated individually as a single point of reference for the pilot, or they could, in terms of long-range visualization, pairs of the cameras could be combined and moved in unison so that it basically provided a kind of rudimentary three-dimensional viewing of the exterior of the
Mark, if I could jump in quickly, can I ask I'd like to ask what the tanks are. I think that Jerimiah Popp had asked about these last time. So you've got green tanks and red, and I realize these have been colorized, but
yeah. Let me expand on that. That was something that for a long time it wasn't very clear exactly what this particular feature was. The original witness thought that they were oxygen tanks, but as it turns out, we were never quite able to figure out what it was that would cause that disk above those cylinders to rotate. And it turned out that just in the last year or so, I've had a very gifted electrical engineer that I've been working with, trying to dissect and sort of back engineer, as it were, how the system functioned. And it turns out that those cylinders actually are a series of induction coils that would impart an electromagnetic field to the underside of this disk, and that was what would cause the disk to spin. Something that I had never considered, and was pleasantly surprised to find out that someone looked at this and recognized almost immediately what it meant, what it was. And so we're actually in the process of constructing some rudimentary tests to try and prove out how this mechanism works and what its function was. But the interesting thing about it is that we believe that that disk was actually being spun up for the purpose of functioning as a homopolar generator. Now, for the people in the audience who don't know what a homopolar generator is, you can look this up on the internet, but there are industrial versions of this kind of device that do not have a disk anywhere near this large in diameter, that are producing upwards of 10,000 volts of electrical charge from the rotating disk in the center of the mechanism. And basically what it does is, in simplest terms, you have a conductive metal disk that's spinning at a certain amount of RPM, and it literally, through centrifugal force, throws the electrons in the material out to the edge where they can be drawn away using a brush-like contact mechanism. And it's my understanding that this was the source for putting the tremendous amount of electrical charge that was used on the capacitor array down in the bottom. There was a three-pronged distribution mechanism that would be at the bottom of the system that rotated around and distributed charge to the different capacitors in three simultaneously acting distribution points that were set 120 degrees apart from one another. And this was in order to, because this thing was using a principle that's often been called the B-filled-Brown effect, it would allow the even distribution of electrical power to the capacitors so that you wouldn't have an imbalance in the amount of thrust that was being produced by the array on the bottom of the craft. Now, there are a lot of people that have argued in my discussions with them after I've said these things that the B-filled-Brown effect could never actually lift something off the ground, could never actually achieve the things that Mr. McCandlish has claimed about this particular craft and so forth. But it's only been in the last 4 or 5 years that I actually had a witness that came to me and said that what everyone didn't know was that when you take a bank of capacitors, an array like this, and you boost the charge that is being stored on those capacitor plates to a voltage in excess of 1,250,000 volts, this is a tremendous amount of electrical power, that there is a side effect which basically amounts to a reduction in mass. And the higher the voltage goes, the lower the mass of not only the array, but everything in the surrounding environment out to a certain distance from the array itself. And in fact, the amount of electrical energy that's stored on the array actually has the ability of warping space-time. And this is one of the mechanisms that allows for the tremendous accelerations that have been reported by these kinds of craft, is it literally has the ability to reduce the mass of the vehicle so that these dramatic and instantaneous accelerations. I personally have seen vehicles that use this technology make incredible maneuvers, right angle turns at speeds well in excess of 20,000 miles per hour when measured time to distance. So you know, it's a dramatic technology. It's a lofty claim, but I've seen it with my own eyes. I can tell you that it really does work. It really is. It's true.
Well, Mark, let me put up another view here, and I should apologize if I'm causing trouble with the view screen. I wanted to zoom in. You mentioned the B-field-Brown effect, and so I wanted to show this cutaway, and hopefully I'm not driving anybody nuts. This one is not as pretty, not as many colors, but I think it's definitely better. So these would be, hopefully you can see my mouse, on this central column here. These would be what you're describing. Originally, you thought they were oxygen cylinders. Now you think that they're coils to spin up a homopolar generator, which would be right here in the center with a little spike coming up out of it.
Let me stop you right there. That spike is part of something else. The system involves also what amounts to a very large Tesla coil, with the primary windings being in that large array or large set of coils that's around the outside of the crew compartment, and then there's another set of coils that are on the inside of that central column, and then the induction coils, those cylinders that are below the disc that's in the inside there of the craft, would actually be responsible for spinning up the disc. Now,
which cylinders are we talking about, Mark?
The cylinders that are in the black and white drawing that Tim has brought up, these cylinders that are around the base of the larger central column that runs down to the center.
The up and down cylinders, yeah.
Okay. The vertical cylinders, yeah. The horizontal cylinders that are down there beneath the skirt and underneath the ventral overhang of the crew compartment, those are oxygen tanks used as part of the environmental system, or the trying to remember what the technical term is for, but it's the system they use for breathing.
Now, Mark, you'd mentioned the B-field-Brown effect, and one of the reasons I brought this photo up is, so these would be capacitors, and again, I don't know if you could see my cursor, but these would be capacitors at the bottom of the craft for the B-field-Brown effect, right?
Oh yeah, I see your little arrow down there. If you could reduce the size on the image just a little bit, so we can get the whole thing in there.
Sure.
And maybe center it a little bit to the left, because I have all the other participants sort of in windows that are showing up over on the right hand side there.
Sorry about that. Yeah. Is that a little better?
Yeah, that's great. That's great. Yeah, there you go. Perfect. Yeah, the plates that are you can see on the end of the individual capacitor banks. These are all cast into a single large array. And it's my understanding that at the inner end of each of these packs, the plates that are in there were alternating between positive and negative charge in terms of the distribution of electricity in the system, and that 4 of the plates were tied together with one conductive bar, I guess you'd say, and the other 4, so they basically were like this 4 and this 4 were set up so that they basically tied to 2 connectors that plugged into the bottom of this central column, which is where they got their charge from. Now, this drawing was done back in 1989, just a few months after I began getting the information from the original witness, Brad. And so I didn't know anything about the distribution network or system that was set up in the bottom of this vehicle at the time, in terms of how the charge was accumulated, number one, and secondly, how it was sent out to the capacitors. I had no idea, but I know that each of those individual capacitors had a vertically oriented solenoid that would connect them to the power source, depending on what the flight control requirements of the pilot were. So for example, if you wanted the aircraft to fly to your left, you would supply more power over on the right side of the vehicle and you get more thrust and it would tilt. And in a sense, so the control was kind of like the swash plate that controls the angle of pitch on the main rotor of a helicopter. So if you wanted more lift on one side, the swash plate would tilt in a way that would, pivot the axis, the horizontal axis of the main rotor on a helicopter, and it would produce more of a cut into the air, and it would give you more lift. So this system functions sort of in the same way, except that rather than using aerodynamics, you're using a kind of electrodynamic force of some kind. The other thing was that, as I said before, the witness, this more recent witness, told me that these plates were charged up to 1,250,000 volts before you would begin to see this effect where it would cause a reduction in mass of the vehicle and a certain amount of the surrounding space-time and anything in it. Interestingly, and I don't know if you can see this in the detail, but the capacitors, the plates down in each one of these sections were set up in such a way that the plates in one section lined up with the gaps in the adjacent section. So there was a little bit of staggering where you would have one group of plates here, and then you'd have the other group that would line up with the gaps in between in the adjoining sections. I'm not sure what the purpose behind that was, but I have a sense that it had something to do with a more efficient operation of the system as a whole. So I hope I answered your question.
Yeah, absolutely.